Hello and welcome to Xamarin University. My name is Adrian Stevens, and today we're going to talk about navigation patterns in Xamarin.Forms. Now, when creating applications, we want to arrange the user interface in a way that will seem natural and intuitive to our users, and just as importantly, in a way that allows them to successfully navigate through all of our content. Today, we'll look at several navigation metaphors used in Xamarin.Forms that can be used to display and organize multiple pages of content. We'll not only look at how to use these navigation patterns, but also discuss when to use them. Now, the term navigation is probably intuitive, but let's take a quick second to define it. We're talking about how the user transitions from one part of your app to another. And your app is made up of, well, a bunch of UI pieces. So for example, a conference app might have a home screen, a sessions page, speakers content, details, etc. And these might be implemented as activities or fragments. Now the app's navigation is the set of transitions available to the user. Now when we have a hierarchy of data, it's appropriate to use stack navigation to browse and interact with the content. And the stack navigation restricts users to following a specific path. So for example, if a user is on the food screen, they can only progress to the coffee shops or restaurant pages. Now to reach the sessions page, they must first go back to the home page. Now when moving forward, new pages are added to an in-memory stack and previous pages remain in the stack. When moving backwards, the top page is removed from the stack and is removed from memory. Now this means we're always able to return to a previous page, and moving forward typically means instantiating a new page. The Xamarin.Forms navigation page is what we use to implement stack navigation, and it performs several important functions. It presents some UI, it shows a navigation bar, and it has a content area for the currently displayed page, or top page on the stack. And it owns the stack that holds the pages. Now because the navigation page owns the stack, you must have a navigation page in your visual tree in order to perform stack navigation. And you can see here we're instantiating an instance of NavigationPage and adding it to the visual tree by assigning it to the main page property of the app class. We're also required to have at least one page in the navigation stack. So when creating that navigation page, there's a constructor overload that takes a page type, and it's very common to pass in your first or root page into the navigation page when instantiating. And in the code here, we're passing in homepage. And as long as nothing else is added to the stack, the home page will be displayed in the navigation page's content area and will be the first page the user interacts with. And the navigation page itself provides methods for adding and removing pages from the stack. We can call push async to add a new page, and this new page will be the top page and will be visible to the user. And notice there's a couple of overloads. The first takes the page to be navigated to, and a boolean to control animation. If the boolean is true, the default navigation animation will be shown, and this animation is platform specific, and we can pass in false to skip the animation. And the second overload doesn't include the boolean, and it will always show the animation if available. Now we have similar methods to remove pages from the stack. Calling pop async removes the top page and will show the previous page, and again we can control the animation as desired. Now you might be thinking, why wouldn't I show the animation? And really the most likely use case is when you're restoring state. So if your user was several pages into the navigation stack and they've left the app, you may need to restore state, and you might want to add several pages to the stack but not show the animation so the user feels that they've restored to the place where they left off. Now we've talked about performing navigation by calling methods on the navigation page. But when navigating through a hierarchy of pages, we likely want to trigger navigation from within the pages themselves. So for example, the food page may present buttons to navigate to the coffee shops and the restaurant pages. And it would be convenient to be able to push a new page from the food page without needing to pass forward a reference to that original navigation page. And Xamarin.Forms does provide a way to perform navigation from within any page contained in the stack. So every page has a navigation property. And when the page has been added to a navigation page, so it's in the stack, this navigation property can be used to access that navigation stack. Now, under the covers, the navigation property contained with every page is an implementation of an INavigation interface. Now, this isn't really necessary to know to perform stack nav, but it is interesting to see how the Xamarin.Forms team solved this problem. When the page is contained within a navigation page, the navigation property connects to a proxy object that allows us to access the navigation page stack. And if you want to see the implementation details, don't forget that the Xamarin.Forms source code is open source. You can go have a look. Now, this navigation property exposes both push async and pop async methods. And here you can see we're creating a restaurants page that we want to display to the user. And then we use the food page's navigation property to call push async. It has the exact same parameters and overloads that we saw earlier. And in fact, it's actually recommended to use the navigation property versus calling the methods directly on your navigation page instance, but both will work. So far we've talked about programmatically removing pages, but the navigation page also provides UI to perform back navigation. And this means we're not required to specifically add UI to navigate to previous pages. You'll see a back button automatically appear when there are 2 or more pages on the stack. When the button is pressed, the current page is popped and the user is returned, of course, to the previous page. Now, for devices with physical back buttons or system-provided soft back buttons, so such as Android often does, pressing the back button will also navigate to the previous page, as a user would expect. And if there's only one page on the stack, pressing a system-provided back button will minimize the app. And if needed, the navigation property does provide the ability to pop the current page programmatically, and this is generally rare as users will use the back button provided on the navigation bar. Now, you may have noticed all of the push and pop methods include async in the name, and these are all task returning async methods and should be awaited when called. Now, you should always await these calls and not attempt further navigation until the navigation operation is complete. So if, for example, you attempted to perform multiple navigation operations at the same time, you could corrupt the navigation stack, or pages may appear or disappear out of order. Really, you might not get the expected results. Now that we're using the navigation page for our stack navigation, let's see how we can customize its navigation bar. Now, the navigation bar can provide some important information such as the current page's title, and we have control over some visual aspects. Let's take a closer look at the navigation bar provided by our navigation page. It has dedicated space for the back button and the page title, and it also has a solid background color. All of these things we can control. The page class has a title property, and this can be set in either XAML or C# as we see here, and when a page is displayed within a navigation page, the navigation page will read this property and display the contents on the navigation bar. Now think about this. This means that each page actually owns its title, and the navigation bar just reads it and respects it. Now we can also control the background color and text color of the navigation bar. Now this is done by assigning the bar background color and bar text color properties on the navigation page itself. Now this is typically set once for the entire application, and the color assignments will remain when navigating forwards and backwards. And so unlike the title, it's the navigation page itself that owns these properties. Now, an interesting point of customization is the back button text, and this is often an area of confusion. Now, on iOS, the title of the previous page will be displayed as the text for the back button. So if this title is long, it can take up a significant amount of space on the navigation bar and can even push the title of the current page to the right. And when it gets too long, it really just looks kind of sloppy. So we can provide an alternate title for the back button. And this is typically to shorten or simplify the displayed text. We do this by calling the static NavigationPage set back button title method. The first parameter is the page you're customizing, and the second parameter is the new text. So you're effectively setting an alternate title for a page. So look at the code. We're updating the back button text for the restaurants page, and this will only be seen when you navigate one level forward or navigate past the restaurant page. So another way to think about it is the previous page owns the text for the back button, not the current page. Now it's possible to be notified when the back button is pressed by overriding the onBackButtonPress method for a specific page. This will allow you to perform custom logic or cleanup, but it also allows you to override the default back button behavior. So if you return true from this method, Xamarin.Forms will not navigate back, so it won't pop the stack. And that means that you'll be responsible for performing the navigation programmatically. Now, alternatively, returning false tells Xamarin.Forms to perform the normal back navigation. And this will allow you to do some custom code, but still let Xamarin.Forms handle all the navigation. Now, be careful when returning true. If you need to block the back button navigation for any reason, make sure it's very clear to the user why you prevented them from returning to the previous screen. Now you also have the option of hiding the back button on the navigation bar from within each page. Now you'll be responsible for providing your own UI in this case to navigate back. And remember, users can still pop the stack by using the system provided back buttons on some devices. And the back button isn't shown if you're on the root page. So if there's only one page in the stack, you're not going to get that UI because it's not necessary. Now in this section, we'll learn how to display pages modally. And modal presentations are typically used when we need to ensure a response from the user. We'll first learn how to display a page modally, and then we're going to discuss when this is appropriate. And we'll also discuss why using modal pages on mobile devices presents some unique challenges. Now, there are times when we want a user to complete an action before navigating away from a page, or we need the user to specifically clarify if they wish to save or cancel an operation. So take a look at the examples here. So when editing a contact, what should we do if a user navigates from this page? Do we save the current state? Do we throw away the edits, or do we cache the changes so they can come back later? All of these are reasonable, but it's not going to be obvious to the user what will happen if they navigate back from an edit screen. It would be better if we could prompt the user to make a decision, ideally by providing save or cancel buttons. And that's exactly what happens here on Android. Now, how about taking a picture? Should we allow the user to navigate away without explicitly canceling? Well, you might say yes, but what if the picture is required to complete a profile, or what if we're replacing an existing picture? Now, modal pages are a good option when we need a response from the user. Modal pages are presented above any existing UI. And on mobile, this means a full screen piece of content that effectively covers or blocks any underlying UI. Now in desktop environments, modal windows often float above the rest of the UI, but they still block access and they block interaction to the windows below until that modal content is dismissed. So with modal content, we often provide specific and concrete actions to perform before dismissal. And in the case of mobile platforms, again, that existing navigation UI is hidden. So in this example, the iOS clock application uses tabs to navigate between sections, but the tabs are not available, and they're not even visible when editing an alarm. We don't want the user leaving this page without pressing save or cancel. And before we see how to present pages modally in Xamarin.Forms, it helps to understand how modal pages are managed. In Xamarin.Forms, these modal pages are also stored in a stack. Now this is similar, but it is independent of the navigation stack. And we have the second stack because it allows us to display multiple pages modally. So a modal page can display another modal page. And we'll discuss the implications of this in just a moment. Now the modal stack is always available. Now contrast this to the stack navigation, where a navigation page must be instantiated and it must be added to the visual tree. So this means that we can always present a page modally, regardless of the overall navigation structure of the application. So a common question arises: why do we have two navigation stacks? Well, let's compare the two. Well, both stacks allow for push and pop, and both stacks are read-only, meaning that we can't manually edit the stack beyond the methods provided by the API. However, we do have more control over the navigation stack. The navigation property exposes methods to insert and remove pages from the stack. And the navigation stack comes with a navigation bar, which, as we've seen, provides both the back button functionality with no additional work and includes space for a title. And ultimately, the navigation stack is a more complete navigation solution versus modal. Now let's look at the APIs used to push and pop pages modally. Again, they're defined in INavigation, meaning they're available on every page's navigation property. So we can use push modal async to display a page modally and pop modal async to dismiss the modal page. Here's an example of displaying, well, a modal page. We instantiate a new instance of our edit page and we pass it into the push modal async method. And to dismiss, we'll call navigation pop modal async. This is typically done from within the modal page itself. So as discussed, pages displayed modally do not include a navigation bar by default. So that means there's no automatic UI to dismiss a modal page. So it's our responsibility to provide a way to dismiss the page, and that allows us to control the navigation flow, and it gives us the ability to ensure the user makes a choice before closing the page. And commonly this will be save or cancel, but it will be context dependent. However, we do need to consider devices with hardware or system provided back buttons. The system provided back button will still dismiss our modal page, and that can lead to challenges or potentially unexpected behavior if we as developers don't make it clear what happens when they press the back button. So we have the ability to override a page's on back button press method. So this gives us an opportunity to do an additional step or do some additional work before the page is dismissed. Now it's up to you, the developer, to decide what should happen here. So you could decide that if the user presses the system provided back button, that you're going to implement default behavior. So assume the user intends to save any entered data, or assume that it means cancel. And there isn't a right answer, and it's going to depend on the content presented, but generally if you're showing a save button, the user will assume back means cancel. Now optionally, you can block the page. You can prevent the page from dismissing by returning true. Now in this case, you need to provide UI to indicate to the user that you expect them to make an unambiguous selection by pressing save or cancel, for example. Or you may present a dialog telling the user what will happen if they choose to leave the page. Now the best choice will depend on the purpose of the page and whether your application absolutely must have a concrete answer from the user in order to continue. If you have especially sensitive data, you don't want to make an assumption about saving or canceling. You might have to make the user make a choice. In our final section, we're going to use another common navigation pattern known as tabs. In Xamarin.Forms, we'll use a tabbed page to manage tab navigation. We're going to learn how to create a tab page, populate it with content, and add images to each page's tab. Most likely you're familiar with tab navigation, but let's again define it here. Tab navigation is a navigation pattern where a tab strip, or really a row of touchable controls, is permanently displayed at the top or bottom of the screen. Users tap on the tabs within the tab strip to change or navigate between content in the application, with each tab displaying a specific section or page of UI. Now, since the tab strip is always visible, tab navigation allows users to quickly switch between sections or content in the app. And tab navigation is ideal when an application has several sections of content that a user is likely to use frequently. So a clock application, that's a great example. The clock, alarm, and stopwatch sections are all useful and may be frequently used. Now, on mobile devices, users tap the tabs with their fingers, and this means the tabs must be large enough and spaced far enough apart to avoid accidentally clicking the wrong tab. And this also means we have a limited amount of space we can use to display our tabs, and we generally have a fixed number of tabs that can be presented. Now with Xamarin.Forms, we recommend to use 3 or 4 tabs. Any more, and you're not guaranteed to have enough space to show all the tabs on the device. Now every operating system supported by Xamarin.Forms has the concept of an overflow, and this provides additional UI to access tabs that don't fit on screen. However, this requires additional steps for the user. The sections are far less discoverable because they're generally hidden behind ellipsis, and generally this is not recommended. And if you need more than 4 tabs, consider using another navigation pattern like master, detail, or drawer, and this is covered in our Xamarin.290 class. So let's see how we implement tab pages in Xamarin.Forms, and for that we're going to use the tabbed page. This is a page-derived type, and the tab page automatically provides a set of tabs, or the tab strip. Users tap on a tab to show the related content. This is displayed in the content area. The tab page uses native controls on each platform, and therefore the tabs are positioned as they should be on each platform. And for example, on iOS, they appear at the bottom. Now, to use tabs in Xamarin.Forms, we're going to create an instance of a tabbed page and then assign it to the app class's main page property. It is not recommended to nest a tab page inside other navigation types, so it should always be the root page in your application. Now, the tab page instance will hold child pages in its children property, and a tab will automatically be displayed for each child in the children property, or in that children collection. So here's an example. We create a tabbed page instance, and we're doing this here in the constructor of the app class. We instantiate the child pages and add them directly to the children property, and then assign our populated tab page to the main page. And we typically populate all the children at application startup, and this differs from stack navigation where we instantiate pages on demand. Optionally, you can create a tab page XAML derived class, and this allows you to assign children in XAML. Now there are pros and cons to this approach. It does encapsulate the tab page and places less code in app.cs. However, if your child pages require constructor arguments, the XAML can become complicated. Now there is a tab page template included in Visual Studio that will create a blank tab page for you, and you can do this by hand or you can use the template. As mentioned earlier, tabs are automatically created for each child page, and the text on the tab will be the page's title. And optionally, you can add an icon to the tab. Currently, icons are only shown for iOS and Android, and the icons must be stored in the appropriate platform-specific or head project. So we put them in the drawables folder for Android and in the resources or root of your iOS project. And you can customize the colors of the tab strip on your tab page. So this is for the entire strip, but you cannot customize the colors of the individual tabs. And you'll set the bar background color property to change the background color, and you set the bar text color to change the text color. This is done right on the tabbed page. And when a user taps a tab, the tab page automatically updates the content area with the associated page. Now this might seem obvious depending on your development background, but this actually is an added benefit. Native Android UI development, for example, requires additional work on your part as a developer to update the content area. And this brings us to the end of our course today. Thank you so much for joining me, and I hope you've got a much better understanding of how to implement both stack and tab navigation in Xamarin.Forms and customize the UI. We saw how to customize both the navigation bar and the tab strip. We also talked about displaying content modally and when that would be appropriate. And really, it's a great option when you need an isolated page of content or you really want a decision made from the user. If you want to learn more about Xamarin navigation, please check out Xamarin.290, where we look at drawer navigation and master detail. And of course, head to university.xamarin.com for more great training on mobile, .NET, and Azure. Thank you very much.